Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.125. While solving this problem, we will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.125. Find the value of K in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of K. So without wasting time, let's proceed towards the solution. First of all, we will simplify this network in order to make calculations easy. These two resistances are connected in parallel connection, so we can find their equivalent resistance and replace that resistance with these two resistances. Their equivalent resistance will be calculated by taking the product of both resistances dividing by their sum. So R equivalent of these two resistances will be equal to 6 kilo ohm. So we can modify the network by replacing these two resistances with a single resistance having the value of 6 kilo ohm. Similarly, we can simplify these three parallel connected resistances. First of all, we will merge these two resistances by finding out their equivalent resistance and merge that resistance with these two resistances. Their equivalent resistance will be the product of both resistances dividing by their sum. So R equivalent of these two resistances will be 7.5 kilo ohm. So we can modify the network by replacing these two resistances with a single resistance of 7.5 kilo ohm. Now these two resistances are connected in parallel connection and voltage across this single resistance 30 kilo ohm, that is V2, will also be appearing across 7.5 kilo ohm because of parallel connection. So if we find the equivalent resistance of these two resistances, so same voltage will also be appearing across the equivalent resistance as well due to the parallel connection property. So rather than calculating voltage across this single resistance, first of all we will merge these two resistances by calculating their equivalent resistance, and then we will use this series current to calculate voltage across that R equivalent, and that same voltage will be equal to V2 because of parallel connection. So first of all we will find their equivalent resistance by taking the product of both resistances divided by their sum. So R equivalent of these two resistances will be equal to 6 kilo ohm. We can modify the network by replacing these two resistances with a single resistance of 6 kilo ohm. Now whatever voltage appear across this 6 kilo ohm resistance, this same voltage will be appearing across that three parallel connected resistances, and we can say that voltage across this 6 kilo ohm resistance will be equal to V2. We are interested to calculate the value of voltage V2 because in order to calculate the value of K, value of voltage V2 should be known. Now voltage V2 will be calculated using Ohm's law. If we focus on this network, this is converted into a series connection, and we know that in series connection the current remains same. So current through this constant current source, that is 3 milliampere, will also be passing through this 6 kilo ohm resistance as well. So we can calculate voltage across this 6 kilo ohm resistance using Ohm's law. V2 will be equal to product of constant current 3 milliampere and the value of resistance 6 kilo ohm. It will become 18 volt. Again, using the property of series connection, we know that in series connection current remains same. So we can say that current of this constant current source will be equal to current through this dependent current source because of series connection. So using this information we can solve this problem. Current through this dependent current source, that is K times V2, will always be equal to the current of this constant current source due to series connection. So K times V2 will be equal to 3 milliampere. In this equation we know the value of V2, so replace V2 with its value. Now divide on both sides with 18 to calculate the value of K. That will become 1.67 multiplied by 10 times minus 4. So this was the last problem of chapter 2 exercise. In upcoming videos, we will start solving chapter 3 learning assessments and later on chapter 3 exercise problems. So stay tuned with Creative World. Thank you. See you again in next video.